For this section, we will be multiplying polynomials. All right, so when we multiply polynomials, we're going to be using some of the rules of exponents we used back in sections 5.1 and 5.2. And so when you're looking at these, you're going to see some similarities on at least some of them. Okay, so when we multiply these two, we're basically multiplying two monomials on this first example. All right, and I'm right here. And so I'm simply going to take 7 times 10. X times x would be x squared, because remember they each have an exponent of 1. Y squared times y to the 7th would be y to the 9th. We add the 2 and the 9. And then on the z's, we have 11 plus 1, so z to the 12th. All right, and so we've taken care of all of that. Now, this is not distributive property. We're just combining these terms by using a product, right? The product rule says that we're going to add exponents. With numbers, we just treat them like we always have, and we multiply them. On the next one, we're going to distribute 5x. So 5x times 6x and 5x times negative 4. Now, it doesn't matter if they're not like terms when you're multiplying, right? Because I can take 5x times both of these terms, even though one of them doesn't have an x. So 5x times 6x would be 30x squared. Don't forget about adding your exponents as you multiply. 5x times negative 4 would be negative 20x. Okay. Next. So on this one, there's a lot of stuff going on. You might want to put your variables in alphabetical order as you work your way through this, and that might help it look a little bit better, but it doesn't matter. It's okay either way. I think that I will do that as I multiply, but remember that's kind of up to you. Okay, so negative 6, this is a 1, so it will be negative 6. I don't have anything to combine with the a, right? I can't add exponents on that. The b squared stays. And then I have z to the first times z to the second, right? That's a z to the first. So z to the third power. And then on the second term, I have a 1, b-a-z. So I'm going to have negative 6 times 1. And then I'm going to keep the a. On the b's, I have b squared times b to the first. So that would be b to the third power, right? 2 plus 1. On the z's, I have a 1 for each of them. So it's z to the second power. Okay. On the last one, for my distributing, I have negative 6 times negative 3. All right, because I'm taking the term times negative 3b. So negative 6 times negative 3 is 18. B squared times b to the first would be b to the third power, because I add those b's. And then I keep the z. And then just double check, right? Because there's a lot of variables here, and you don't want to make any mistakes on your exponents. And then also remember that if you didn't put them exactly in the same order, it's okay. All right, so on this one, we're distributing negative 8y. So that has to go times 6xz and then times 4x. So negative 8 times 6 is negative 48. We keep the x. We add the exponents on the y's. So that would be y squared. Negative 8 times positive 4 is negative 32. And it's xy. We have an x on the 4. We have a y on the negative 8. So both of those will be part of our answer. All right, moving right along here. Okay, so now we're going to multiply binomials, right? It says multiply two polynomials. We were just multiplying a monomial and distributing on the previous questions. So on this we use distributive property and multiply each term of one polynomial by each term of the other and then combine like terms if needed. Now, I like to use this order. You might have heard of the terminology FOIL, and that is the order that I'm going to show you on this is going to be the very same order that it would be if you used FOIL, which means first, outer, inner, last. I'm not that fond of it because it doesn't work. Say I'm taking a binomial times a trinomial. FOIL doesn't work for that. So we, it's okay. It has its place, I guess. So, all right. So on this, I'm going to first distribute the y. Okay, so I'm going to take the y times 3x, or 3y, the y times 3y, and the y times negative 2, right? So I'm going to have 3y squared minus 2y. Basically, you just want to have an order here so that you don't get confused. And then I'm going to take the 5 times the 3y and the 5 times the negative 2. So 5 times 3y would be 15y. And then 5 times negative 2 would be negative 10. Notice then my two middle terms here, or the two terms in the center of this thing, would be like terms. So I combine those. So 3y squared plus 13y minus 10. You always want to check for like terms so that you can combine them if needed. So you don't want to leave them separated. Once you know how to do like terms, which we learned on section 5.3, then you have to use that on this section. Okay, so distributive property simply means I'm going to distribute the first term with both of the other term, the two terms in the other parenthesis. So on this, I'm going to take 2x times 6x. You want to have an order so you don't leave anything out. And then 2x times negative 2 would be negative 4x. And then I go to the negative 4 and distribute it with the 6x and the negative 2. So negative 4 times 6x would be negative 24x. Negative 4 times negative 2, positive 8. And then, of course, we do have like terms, negative 4x and negative 24x. So 12x squared minus 28x plus 8. So you want to be sure and finish. Don't stop too soon. And also make sure that you practice this order because that helps you as you work your way through this section. For instance, on this question, notice we're multiplying a binomial times a trinomial. So I have to distribute each term. Okay, so also when you're first learning this, you may want to write out more, and that's up to you. So I could say, okay, I'm going to take a times each term. So a times 3a squared plus a times negative a plus a times 5. So there's my distribution of the a term, right? I multiplied it times all three, or I will. I'll combine these in just a minute as I'll do the multiplication actually. And then I'm going to work with the positive 2. So I'm going to say plus 2 times 3a squared plus 2 times negative a plus 2 times positive 5. And this is something, if you feel like I might get lost in this, you can go ahead and write it out this way. And then I'm going to simplify these. So I'm going to have 3a to the third power minus a squared plus 5a. Then it's plus 6a squared minus 2a. And then, right, because that's going to make negative 1 times 2 gives me a negative 2a plus 10. Now, at this point, I do have some like terms right here on the a squareds, and then I also have 5a and negative 2a. So let me finish this up. I keep the 3a cubed. This is a negative 1a squared plus 6a squared, so that would be 5a squared. 5 and negative 2 would be 3a, and then plus 10. Right, because I didn't have anything to combine with the 3a cubed or with the 10. All right, so that was multiplying a binomial times a trinomial. This is the very reason I said that FOIL isn't really the best thing, because it doesn't apply to everything you're multiplying. All right, here we go. So this one looks a little bit messy because we have fractions, and that's okay. You can work with fractions. So we have 4y times 3y, which would be 12y squared. 4 times negative 1/8, right? That's like 4 over 1 times negative 1 over 8, which is negative 4/8 or negative 1/2, right? So we're going to have negative 1/2 y. Negative 1/3 times 3 is negative 1, so I'm going to have a negative 1y. I'm just going to go ahead and write the 1 there. And then negative 1/3 times negative 1/8, I multiply straight across the numerator times the numerator, which would make that a 1. 3 times 8 is 24. Okay? And then, of course, you can always use your calculator fraction key to combine fractions like this. But that's negative 1/2 times negative 1, which ends up as 3/2 y, and then plus 1/24. And that's as far as we can go with simplifying. Okay, so I'm going to stop this video, and then I'll pick this lesson up on the next video.